Hello, my name is Edward and today we're going to be solving problem 29 of assignment number 9. So here's the function that will give us the population of raccoons for a given value of t, which will be in months. So to solve part A, which asks to find the value of t when we have the highest population of raccoons possible. So to do this, we need to find derivative of the function p. So this we're going to be doing. So p prime equals the derivative of this is 120 because it's a constant times a variable. Then we have the power rule over here, so we're going to bring down the 4, so you can do it like this. And now we need to convert the decimal into a fraction, and they're both multiplied by each other. So we get this 4 over 10, and we get t free, and the derivative of a constant is 0. So to summarize here, we lowered the power by 1, so we get t free, and we bring the 4 down, so we get in the end 4 times the decimal, which is now a fraction. So we're going to simplify this. So it's going to be 120 minus 4 times 4 is 16, 1 times 10 is 10, so it's 16 over 10. We can simplify that to 8 over 5, t free. That is our derivative. Now, we need to find the critical value, and to do that, we need to go. We need to set p to 0. So 0 equals the derivative. Like so. So we're going to bring 120 to the other side, so we get 120 equals 8 over 5 t free. Going to divide both sides by 8 over 5. And then what we get is 75 equals t free. So we need to square cube both sides, so we get t on its own. So we get t equals to 75 to the power of 1/3. And if we put this in calculator, t is roughly equal to 4.22. So 4.22 months. All right, so that's part A. Now for part B, which will be finding the value of p, basically number of raccoons, like the maximum number of raccoons. So to do that, we simply plug in this value in the original function over here. So to save time, I won't necessarily do it, but if we plug in 4.22 over here and over here, we get a final number of 1,079 raccoons. Or around 1,079 raccoons. That's the highest population for this given function. And lastly, for part C, since we're given a graph, we can simply find in the graph where y equals 0 to find the value of x. So in that scenario, sorry, not x, the value of t. So t is roughly equal to 8.03, like by looking at the graph. And that's how we solve for part C. All right, that's all. Have a good day.